Self-ionization of water. As we mentioned earlier, that water is one of the amphoteric substances. That is, it may exhibit an acidic behavior in some reactions or an alkaline behavior in other reactions. Therefore, let us consider the following interaction. Can you identify the acid and the base in this reaction? We notice that one of the water molecules is a proton donor, the acid. The second molecule is a proton receiver, the base. This will produce a positive hydronium ions H3O+ and negative hydroxide ions OH-. As we see, these ions are in equilibrium state with the other non-ionized water molecules. It's called self-ionization of water. As water ionizes, it disintegrates into positive and negative ions, but this disintegration is very weak. This explains the weak electrical current conduction of the pure water. To calculate the equilibrium constant Kc of this reaction, as we know, it equals the concentration of the resulting materials divided by the concentration of the reactants. But according to the fact of weak degree of water ionization, the water concentration is considered constant. Thus, water concentration can be included into the equilibrium constant Kc. So, we can express it using the Kw symbol, which is called the equilibrium constant of water. Kw equals the concentration of H3O+ ions multiplied by the concentration of OH- ions. It's equal to 1 times 10 to the power of minus 14 at 25 degrees Celsius. Returning to the self-ionization equation, we find that the number of moles of H3O+ equals to the number of moles of OH-. This means that the concentration of their ions is equal. Thus, the equilibrium constant of water can be expressed as Kw, the concentration of H3O+ squared, equals the square of OH- ions concentration, and equals to 1 times 10 to the power of minus 14 moles per liter. By calculating the square root of them, we conclude that the concentration of H3O+ and OH- are equal and are equal to 1 times 10 to the power of minus 7. These two equations are important to solve the upcoming exercises. But what is the significance of this? As we mentioned, pure water is a neutral because the concentration of H3O+ is equal to the concentration of OH-. So it can be used to classify other aqueous solutions when substances are added to pure water. Now together we will learn the effect of adding an acid or a base to pure water. If we add a substance to pure water and found that H3O+ concentration is equal to OH- concentration, then we conclude that the solution is neutral. Whereas if the concentration of H3O+ is greater than the concentration of OH-, then the solution is acidic. But if the concentration of H3O+ is less than the concentration of OH-, then the solution is basic. In terms of numbers, when the solution is neutral, the concentration of H3O plus and OH minus are equal to 1 times 10 to the power of minus 7. For the other cases, if we rely on the concentration of H3O plus, as we know that an increase in its concentration in the solution indicates an increase in the acidity of this solution. If the concentration of H3O plus is greater than 1 times 10 to the power of minus 7 in this direction, then the solution is acidic. As we note that we are dealing with negative powers. But if the concentration of H3O plus is less than 1 times 10 to the power of minus 7 in this direction, this indicates that the solution is basic. On the other hand, if we depend on the concentration of OH minus, and as we know, the increase of its concentration in the solution indicates to the increase of the alkalinity of this solution. If the concentration of OH minus is greater than 1 times 10 to the power of minus 7, this indicates that this solution is basic. Whereas, if the OH minus concentration is less than 1 times 10 to the power of minus 7, this indicates that this solution is acidic. Now let's solve some examples together. In the first exercise, it's required to determine the nature of the solution, whether it's acidic, basic, or neutral. If the concentration of H3O plus is 1 times 10 to the power of minus 5. To solve this question, we have to determine whether the concentration of H3O plus is less or greater than 1 times 10 to the power of minus 7. When we compare the values, we start by comparing their powers. Take in consideration that they have negative powers. If their powers are equal, we compare the integers. Now back to our example. The number with 10 to the power of minus 5 is greater than number with 10 to the power of minus 7. So the concentration of H3O plus is greater than 1 times 10 to the power of minus 7. Referring to the line of numbers, we note that the concentration of H3O plus in this region, so this solution is acidic. Another example, if the H3O plus concentration equals to 3 times 10 to the power of minus 12. First, we have to compare their powers, where 10 to the power of minus 12 is less than 10 to the power of minus 7, which means that the concentration of H3O plus is less than 1 times 10 to the power of minus 7, so this solution is basic. Another example where the concentration of OH minus equal to 1 times 10 to the power of minus 4. As we can see, 10 to the power of minus 4 is greater than 10 to the power of minus 7, which means that the concentration of OH minus is greater than 1 times 10 to the power of minus 7, so this solution is basic. In the following example, the concentration of H3O plus equals 2 times 10 to the power of minus 6. When comparing the powers, we notice that 10 to the power of minus 6 is greater than 10 to the power of minus 7, which means that the concentration of H3O plus is greater than 1 times 10 to the power of minus 7. So the nature of this solution is acidic. Another example where the concentration of OH minus equals to 5 times 10 to the power of minus 7. When comparing the powers, we notice that they are equal. So we will compare the integers, where 5 is greater than 1, which means that the concentration of OH minus is greater than 1 times 10 to the power of minus 7. This means that this solution is basic. The next exercise, calculate the concentration of OH minus ions in a solution if you know that the concentration of H3O plus ions equal to 1 times 10 to the power of minus 3 moles per liter, and determine the nature of this solution. To solve this question, we will use the equation of the ionization constant of water, Kw. So the concentration of OH minus ions equal Kw divided by the concentration of H3O plus ions. Then we substitute the values. We divide the integers first and then subtract the exponents from each other. So the concentration of OH minus ions equals to 1 times 10 to the power of minus 11 moles per liter. The nature of this solution, as we have learned, we have to refer to the value of the concentration of H3O plus or OH minus ions. Note that in both cases, the nature of the solution is acidic. Or we can compare the concentration of H3O plus and OH minus ions, where, as we can see, the concentration of H3O plus ions is greater than the concentration of OH minus, and this confirms what we have concluded, that the nature of this solution is acidic. This exercise requires to complete the following table. As we see, the solution is identical to the previous exercise, so we will use the equation of the ionization constant of water, Kw. The first solution, it's required to find the concentration of OH minus, so we will divide the value of Kw by the concentration of H3O plus. Dividing the integers by each other equal 0.25. Then we subtract the exponents from each other, which equals to 10 to the power of minus 10. The nature of the solution, as we can see, the concentration of H3O plus is greater than the concentration of OH minus. This means that the nature of the solution is acidic. The second solution requires to find the concentration of H3O plus, so we will divide Kw by the concentration of OH minus. We start by dividing the integers. The result is 0.5. Then we subtract the exponents from each other, so the result equals to 10 to the power of minus 12. The nature of the solution, the concentration of H3O plus is less than the concentration of OH minus. This means that the nature of the solution is basic. For the third solution, it's given that the solution is neutral. So the concentration of H3O plus equals to 1 times 10 to the power of minus 7. Also, it equals the concentration of OH minus, which is 1 times 10 to the power of minus 7, 2. Big thanks for your watching. I hope you like the content. At the end, do not forget to like, share, and subscribe to receive my new videos.